Hello everyone, welcome to my tutorial series. In this series we will create an asteroid game using Unity3D and Blender. In the first part we will create the player. So if we create an empty game object, and we can call it player, and then we can create another cube inside of it. So we make sure that the transform here is all set to 0, 0, 0. We'll call this the mesh. Okay, so now we can change the z-axis, so the spaceship will have a look of going forward. So this way we'll know that the z-axis is the forward axis in Unity, and the z-axis will be like this. So at this point, so why do we have a mesh object inside the player? That's because the player will have all our scripts about how the player behave, and the mesh will be actually the graphic object that we will have for the player, and these will not change, or these will change. Like if we into the next episode we will create a new mesh object for the asteroid to look like a spaceship instead of just a cube. Okay, so the next thing we'll need to do is to change the camera. So we want the camera here to look from the top to the bottom, to look at the player in an orthographic way. So in here, into the camera, we can change this to orthographic. We can see that it already changed, and we don't see the back of the player anymore, and we can see that there is not a cone anymore here, it's just a square that goes to the infinite here. So if we change now the position of the camera, so what you can do is you click on this little cone here to go to the top view like this. You hit the orthographic view, this button here, and you set it like this. Then with the camera selected, you go to assets, you go to game object, and you say align with view. This will change the game object, the camera, to be the same as the current view, and then you can just put it into the position 0 and change the height just to 1, because then it will be the sides of the camera here that will actually change the sides. I think 10 should do for now. Yeah. So we will come back to the camera later. For now, let's go back to the player, and for this to work we'll need to add a rigid body to the player like this, and then we'll add a new script. This script will be called the Asteroid player motor. Okay, so if we double click on it now, it will open the Visual Studio, or if you're not using Visual Studio, it will open Mono Develop for you. So now in Visual Studio, so we'll remove this dude and we strip out a bit of commenting, and then we'll have a required component here at the top. So what the required component is, it will make sure that Unity, you will not be able to add this script into a game object in Unity if that component doesn't have a rigid body. If it doesn't have it, Unity will add it for you automatically. We will need two variables that we should be able to control from Unity. We will need the torque power and the throttle power. So the torque will actually control how fast the spaceship will turn, and the throttle will control how fast the spaceship will go forward. So if we go on and we create the throttle power and we create the torque power, now we will need a rigid body, so we create private rigid body, just a name variable, and into the start method we do get component rigid body. This is actually important because we don't want to do the get component every time we go into the update method, because the get component is not a cheap operation, so we want to do it just once when the game object starts up. So the start here will be called from Unity when the game object is enabled for the first time, while the update will be called from Unity every frame. So into the update, what we want to do is getting the input from our keyboard. So what we will do, we'll create a new variable var torque input. This will be input.getAxis row horizontal, and then we will have the throttle input. This will be getAxis row vertical. So the get axis, the input.getAxis, will allow Unity to get an axis that we configured into the input section of the editor. We can have a look at it later, and there are actually two methods. One is called getAxis and the other one is called getAxis row. So the getAxis will return a number that goes from -1 to 1, and you'll get all the decimals. If you use the getAxis row, you won't get the decimal. You will just get -1 and 1, or 0 if you're not touching any of the axes. And because in Asteroid the spaceship just go forward, it doesn't go backwards, so we will need to clamp the throttle input, and we can use the matf.clamp. So this is throttle input, and the minimum will be 0 and the maximum will be 1. At this point we will need to tell the rigid body to actually do something with the input, but we don't want to do this into the update. When you have to apply something to a rigid body, we want to do it into the fixed update. The fixed update is a special update for physics. So in here we want to add the rigid body, the relative force forward multiplied by the throttle input that we don't have in here, and multiplied by the throttle power. And then we can say force mode force. So in this way we will need to set the throttle input and the torque input as global variables, so we can declare them in here. So throttle input and torque input, they will be set into the update method, and they will be used into the fixed update. So this will be, thanks to this add relative force, basically we'll add the force into the forward direction of the rigid body, and we will multiply this force by the throttle power, which is configurable into the Unity editor, and we will multiply it by the input that we set into that. It will be just 0 or 1, so that it will be apply the force or not apply the force. For turning we add a torque. So we will have the torque will be applied on the vector 3 up. This will be the axis where the actual game object will rotate, and then we'll apply force mode dot force as well, and we'll need to multiply this by the torque input and multiply again by the torque power. Back into Unity, into the inspector, we now see throttle power and torque power in here, so we can set some values in here and we can hit play. And if I turn, we can see the asteroid spaceship is turning, and if we hit forward, then the spaceship starts to go forward, and this is kind of a lot like what an asteroid game will look like. classic thing in Asteroid though is that when you go out of the screen, you come up on the other way of the screen. This is not happening at the moment. So what we will need to do is add something into our script to make sure that this happen. So what we want to do here is that we want to get the position of the player, and we want to know where it is into the actual screen and not into the world. So for doing this, actually Unity, it gives us a very useful function that is called world to screen point that we can use. So if we start creating a new variable, we call it an on-screen position, and for getting the screen position of the player, we can access the main camera, and we just call world to screen point, and we pass in the actual position of the player, like this. And now we just need to check if the player, the screen position of the player, is outside of the actual screen. So for doing that, we can do the if on screen position dot x is less than 0, then the player is outside the screen on the left. So we can create a new variable here. We'll call it var new position, and we initialize it to the on-screen position, and we say new position dot x equals screen dot width. So this will mean that the screen dot width and screen dot height, they will be the actual width and height of the current screen. So when we go to the left of the screen, then the new x position will be the maximum on the right position. The other way around, so if the on-screen position dot x is greater than screen dot width, then the new position dot x will be 0. And then we need to do up and down. So if on-screen position dot y is less than 0, then new position dot y equals screen dot height, and if on screen position dot y is greater than screen dot height, then new position dot y equals 0. Right, now what we need to do, so we might want to see here that we are setting x and y, while we know that actually for Unity it's the z-axis that's the one we are moving on, and not the y-axis. That's because the screen coordinates, they work differently. In screen coordinates we just have x and y. The z-axis is always 0. That's why the y-axis will actually be our z-axis into the 3D world. So now we want to have the transform these screen coordinates to world coordinates again. So we can say var world coordinates equals camera dot main dot screen to world point, and we can use the new position here. Right, so at this point we can just set the transform position to the world coordinates. Actually, instead of doing that, because we want to ensure that the y coordinate always stays to 0, we can do world coordinate dot x 0 and world coordinate dot z. Perfect. Right, so we're back to Unity now, and if we hit play, if we go out the screen, then here we are on the other side. Fantastic. And if we try the same on the side, yes, it works. Perfect. So now that you have the setup for the player, then you can play with the throttle power, the torque power. You can add more angular drag or normal drag, and until you have a model that works for you until you feel that the actual player will move as you want to. And that's it for now, and we'll see you on the next tutorial.